Well, they'd rather see source code that looks like what they're used to.
So your request is, hey, could we get this feature back in time? And the answer is no. I don't mean that as a joke. I mean, there's a lot of features which we'd love to get. When I was programming C#, I wish I had generics. When generics came out, did I get to go get them in C#? No, it turns out I didn't. In fact, then I couldn't even reference something that used them. So I like the request. I'd love to do that, but we don't backport language features into earlier versions of the language, which I think we ultimately actually don't want because it would start to break a lot of code. Yes, in the back.
One oddity, I think, of this whole thing is you can program against, you can set your tools to C#7, even if you're still using an old version of the runtime. And to me, that's just bad.
Sorry, say that again. You can what?
So if you select C#7 or 6 as your target for your project, but you're still targeting .NET 4.5.0 or 4.0.
So you can target a different framework and still use C#7. And you're saying you don't like that.
The problem is some features work and some don't. Depends on whether you need runtime support for the C7 feature.
I don't believe there's, well, I don't believe there's any feature that you need runtime support for. And this is a great example, right? I can go ahead and program for C# for .NET 4, blah, it doesn't matter which one. And I can use value tuple, and I can return that in my public API, and I can still go ahead and access that from a library that does not support C#7. So there are not any, I can't think of any, and I'm pretty confident about this, there are not any features in the language that prevent you from being callable by somebody in an earlier framework. Now, the one thing that I've talked about is you're going to have to reference a NuGet package. The NuGet package is system.valuetuple. But it turns out that you have to do that in C# 7.0 anyway. Important note, if you use tuples in C# 7, you have to reference a NuGet package in order to use the feature. And if you don't reference a NuGet package, you're going to get a warning with some weird message that you're not sure exactly how to resolve. You just got to reference system.valuetuple. That is until you get to .NET Standard 2.0. Because in .NET Standard 2.0, we add system.valuetuple to the standard, and therefore it's included in the framework. And so as soon as we go to .NET Standard 2.0, this issue disappears, and it will never be remembered again. Yes?
I'm sorry to ask this, I'm sure you've already explained it pretty well, but what is included in the NuGet package that isn't in C#?
So the question is, tell me about this NuGet package again, and the answer is, there is a NuGet package out there called system.valuetuple, and it has one type in it. Guess what it is? And I personally think this is a pain. Like, I would like the IDE to automatically give this to me, and it'd just be done. And it turns out in C#, in the new IDE, which I'm probably using, you mentioned like old versions. Like I only know one version. It's the current version, or the one that's going to be the current version. So you want this feature. Allow NuGet to download missing packages, and automatically check for missing packages during build in Visual Studio. So what it does is it'll actually give you IntelliSense around to doing this. I don't know if that's the right one. There's a checkbox you need to check, and that'll allow you to go back to what we had in C#. Visual Studio 2015, maybe it's 2013, I don't remember. But there used to be a time where you could do control dot, and it would say, hey, do you want me to add this NuGet package? And you'd get it. And that feature disappeared, and now it's back if you check the checkbox to get it. And you're gonna want to do that. Okay. The next up is details. There's one more feature I wanted to show you that I think I might have missed out here. If we go back to this guy. Hello? I have this really powerful computer with like tons of processors and stuff like that. You can tell. Okay, so while it thinks about what I'm trying to do, remember we had the... did I mention I'm using a preview build? I am using a preview build. So I'm going to talk about this. If you need to close your eyes in order to imagine what I'm doing, but no matter what, imagine great syntax, perfect typing. Okay, so here's the deal. Remember that method we had that returned 3 out parameters? It was called split path. And then I overloaded it by having split path. It actually returned a tuple. You can call that method and assign it to a tuple and never specify the out parameters.
That means you can do legacy, use legacy code in that fashion, right?
Yes, if you're programming in C#7. So let me just be clear. We had a method called split path that took a path parameter and then had 3 out parameters: directory name, file name, and extension. And when we invoked that method, I showed you that you could go ahead and declare in line, when you invoke that function, you could declare the variables. Instead of doing that, which I would still argue is a pain, you could remove the out parameters entirely from the invocation and assign it to a tuple of 3 type parameters. Yes?
What if your function also returns a value?
What if your function...
So you have a return value plus 3 outs.
I don't think you can do that. Good question.
Try parse that returns a tuple. It would just have to be a tuple.
What was I doing?
Or you'd have to assign it to China or something weird like that.
Sarah, comment.
I can't think of any good use for that, but.
You can't, of the one I just mentioned?
No, I can't think of any good use why you have a function that returns 1 value that has like 3 output parameters.
Oh, yeah, no, I've done it. You've got a Boolean for success.
Yeah,
And then,
yeah, try parse. Well, try parse usually just has the 1 out.
yeah, but it's also got the Boolean.
would be the tuple.
Yeah.
So just so we're clear about what I'm trying to do here, let me open this guy again. You can do this.
Need a variable.
You need a variable, right?
Oh, come on,
Yeah, very
details.
So now you don't use R.
There we go. Make sense?
Yeah.
So you no longer have to use the out parameters. Thank you for the help with the syntax. Okay.
If you had done var without the string, would it have interpolated that for you?
Yes. Not on that. Well, it would in this case because I overloaded it and I have the
Oh, that's
function
true.
that does it.
But in general, it won't.
Okay, next. So, looking at value tuples. What I'm hearing is that some of you find this feature controversial. And you're free to do that and you're free not to use it. In my experience programming, I found this to be very useful certainly in every single case I wanted to use anonymous types, and I don't know if I've handled your objection yet. But I find it a lot more useful for anonymous types because I can pass the variable around outside of my function. And that to me is pretty important. Did I handle your concern even sort of? You said no, I
We
prefer
can talk
anonymous
about
types.
it. You can.
Okay.
It's okay. You don't have to. It's more complex for frameworks.
Yeah, the bummer is that like if you pass that thing to a serializer, it has item 1, item 2, item 3 in it instead of the names. That
That's the
you provided.
canonical example.
Well, not if your serializer knows to look for the attributes, right?
No, the attributes on the method.
So the serializer could be updated to do that, but it hasn't been and it won't be. I mean, the reality of it is because you want to be cross-typed. So I think you're not going to get those names to persist. But I would argue with anonymous types, you don't really get that either, right? I mean,
In method.
yeah. So here there is one exception. It turns out, and this is, I just think it's not even worth mentioning, but since you guys are bringing it up, it turns out that reflection might be, if you're doing reflection on an anonymous type, that might be the one scenario where you might prefer to have anonymous types. But I would suggest that that's such a corner case that the general rule of saying use tuples everywhere is probably the correct. The other scenario, again, since we're getting to the details, a value tuple is a value type. And it is a value type that has a bunch of fields, which also breaks a whole bunch of coding standards in the past that we've had. So, and we can talk about that too if you want. But it turns out that if you need, for some performance reason, to have a class or a reference type rather than a value type, then that might be the other scenario. But like these are really corner scenarios that you would have to think really hard about coming up a real world scenario that, oh yeah, I actually need to have a reference type that uses reflection, blah, blah, blah. So let me deal with the point that is they are fields. So we are now have a value type that is a field, and the value type is not immutable. Right? It is not a immutable value type. So you can change the values in this value type. So, ever since C# 1.0, we said, okay, if we're going to go declare a struct that is a value type, we should make sure that it's immutable. And we went through a fair amount of work to declare our types as immutable, because it turns out it's harder to declare them as immutable than it is mutable, even though the coding standard says declare them immutable. It became a lot easier in C# 6. So part of the reason is because we use properties, and when you use properties, when you did a plus notation and you incremented it, it didn't change it. It changed it for the property, but it didn't actually change the actual underlying value. But since we're using fields, I can now go ahead and assign a tuple and sort of modify the tuple on the fly using plus plus or plus equals, and it turns out that change does get persisted into the type because it is fundamentally the simplest thing you can possibly have, which is a value type with fields. And so we've sort of got a scenario which is like the one weird scenario where you actually turns out you can have where you can have a mutable, I could say a non-immutable, but let's just go with mutable, a mutable value type that has fields, so you can now modify the fields with things like plus plus, and it would actually work, the increment operator. Yes?
So I guess the one realistic one that you can touch on here is number of fields you can have, which I believe.
Oh yeah, so great question. So the issue is, hey, there's only the most generics you can have on a tuple is a value tuple with 8 generic type parameters. And that's true, but the 8th type parameter is something of type value tuple, which means that I can essentially go on forever with as many tuples as I like. And in fact, if you use C# syntax, you can do that and just code it with 9 or 10 or 13 or 15 parameters, and the underlying compiler takes care of all the details, and you don't have to know about it. And so I would argue that I would be cautious in getting above like 8 or even 7. I think you're starting to get a bit ridiculous in terms of the number of parameters you have. But if you do decide you need 13 type parameters, the underlying infrastructure will automatically change the compiler to go ahead and use a value type that allows you to have the last parameter as being the remaining items in your tuple. Yes?
What are the memory utilization impact? I mean, you're now talking about your value types, so you're talking about you throwing this on the stack now. And I can see Stack Overflow happening pretty quickly when you get a semi-complex.
Pretty quickly?
Depends on how much large a data structure and data set you're dealing with.
Yeah, so I think the rules are again, a lot of these cases, the rules are the same, right? Don't go use value types that are over, I think, 128 bits, I think is the general coding standard. And so you should be cautious about this.
I mean, it's easy to pull from a database something that's 40,000 characters into one field. So
sure, but you don't tend to use those things and then pass them. I mean, I guess it's sort of how do you use it? Do you need to be conscious of how you use
That
it?
would still be,
Yes.
I mean, that's a string, and that's going to be heap allocated.
If you use it as a string, it doesn't necessarily need to be a string, right? It could be an int, right? So
Or
at the end,
even a byte array or whatever it
Yeah,
might be, it's going to be heap allocated.
okay.
Are there any restrictions for using the tuples?
tuples, you mean?
Tuples instead of regular variable? As far as, I don't know.
It is a standard data type. The only difference is that you now sort of have a new literal, right? Before, when we had a literal string, we've now got a literal tuple. It's put parentheses around and separated by columns, by commas.
You could call it as a constant, right? You could make it a constant.
Can you make it a constant? No. No, you can't. Because the data that you're assigning it to is not a constant. You can modify it. Right? We can only use const for things that have literal like strings and ints and things like that.
Same way you do the constant equals equal something.
You can't use a const on instruct. One other thing I should mention, since we're getting into corner cases here. Yes, you can use read-only, no problem.
Yeah.
Okay, since you guys are so excited about tuple, I'm going to keep going. Let's imagine, it turns out, when we go ahead and call constructors on an object, we go ahead and pass in a bunch of parameters, and we construct or encapsulate an object. What is the function we call to do the reverse? No, a destructor does something different. First of all, it doesn't exist in C#, but a destructor, is to do with memory utilization, right? You go back to deterministic finalization, those kinds of scenarios. It's about memory management. Destructor, at least in the context of C++, and languages like it, is about restoring the memory, or returning the memory. So we sort of have this idea of this. It's very easy for us to construct things into an object or encapsulate it, but to decapsulate it or deconstruct it, we don't really have any magic way to do it. But what we would do is we'd go declare a method, like I have here, and I would go ahead and invoke the method and say, hey, now go ahead and give me back the constituent parts of this class. And I could do that with multiple deconstructors. I can overload it, as I'm showing you there. But what if I could do this? It's really hard with my... What if I could do that? So here I'm reassigning. So the first way is this how I would call construct. This is how I would call my deconstruct method. Just like I showed, it's a standard. There's nothing fancy about this. But I could also do this.
Because path info was a tuple.
No.
Path info was a class. That's
Nope.
right.
Oh, it's a
Destructor.
The small p?
Yes.
See,
All
not
these
even in
instances
this
of
room.
class.
No, it's just.
If you have intro property names.
So here's what I'm saying. How do I take my type, my path info type, which is just an instance of my class? I can deconstruct it into its constituent path, and it would automatically say, hey, I know how to deconstruct path info, and assign it to a tuple. There is no method invocation here that you can see explicitly. It is entirely implicit. This is what the compiler is doing. It says, do you have a method called deconstruct that has 2 or more out parameters? And if you do, I'm going to go ahead and invoke that function. Now, there's... would you like me to say backwards?
No, you can go.
If you have a method that is called deconstruct that has 2 or more out parameters, you can assign it to a tuple, where the tuple corresponds to the number of out parameters. Now, a couple things that I would mention clearly, because I get the idea that you guys are really sticklers about features and which ones you like and which ones you don't like. It is not obvious from this code that I am calling the deconstruct method. Let's just put it right out. There's nothing in there that shows that I'm calling a deconstruct method. However, it is clear that I'm taking a path info and deconstructing it into its constituent parts. That is true. Do I need to know the details of how that happens? Do I actually need to call the deconstruct method, or is it okay to do it implicitly? If you would like to go and call the deconstruct method explicitly, you should do that. If you're okay with this syntax, you should do that. Either way, the same invocation happens. Yes? Can you overload the deconstruct method? The answer is absolutely. In fact, I did. I had one with 2 parameters and one with 1 parameter, which allows me to go and decide, in this case, to a tuple with 3 type parameters or a tuple with 2 type parameters. You cannot do this with 1. Okay, so my language is clear. You can write a deconstruct or use the deconstruct method and this syntax with 2 or more. If you want to use 1 parameter, what would that be?
Yes, that'd be a sign.
Brilliant. You guys are faster than any, I've done this talk all over the world actually, and you guys have come up with the answer fast enough. It turns out if you want to do with one, you should write a cast operator. And we don't, and they're different, right? So, I asked the question to the team, hey, like, why don't you just allow me to do one? Like, we've got a way for doing that already. Use cast. Okay, so one is not supported, it has to be 2 or more. Great, yes?
Does C# offer an implicit deconstruct method where you don't have to write it at all? And it'll just implicitly do that?
The question is, does C# offer an implicit deconstruct method? And the answer is no. You must go declare the deconstruct method. Is this a breaking change to the language? We are taking a magical method name. What happens if I have a deconstruct method in my C# 6.0 code?
I would have preferred that you created at least a hint like an I deconstructible.
I deconstructed.
So that you could throw it on your class saying that it supports it.
So, okay, fair.
You
Fair.
implement this as an extension method on existing?
Can you do this extension method? I don't know. I don't think so.
It doesn't seem like a breaking change, because it would only work, it would only come about if you happen to have a deconstruct that had output parameters, right, already.
Well, but what if I did?
But then you would just get a constructor, and you just get a tuple, who cares?
No, so nobody in C# 6 wrote this code. The only thing that the deconstruct method is the ability to write this code. If you had the deconstruct method
Right.
before, then you automatically have the ability to go ahead and assign this. There is no breaking change, in spite of the fact that I'm now having a magical method name, which is actually fairly rare in C#, just to be clear. We don't usually have magical names for anything. There are a few corner cases.